Okay, so in the last class, we started with the quadrilaterals chapter, and today we were doing the types of quadrilaterals. We will finish the chapter today, and after that, we'll find some questions. So let's begin. What quadrilaterals we have done already? Can anyone tell me?
Parallelogram.
Yes, and
We did trapezium, parallelogram, and rectangle.
yes,
The
very
square.
good. Um, no, we did trapezium, parallelogram, rectangle. We'll do square today. Okay, square rhombus, right? We'll do today. Alright. So let's.
Ma'am,
Yes, Anju.
I'm wrong spelling, ma'am.
DRI.
DRI.
Let's begin with the square. So we have a square, and what's its speciality? If I say a square, what is its speciality? All sides are equal. Let's name it first. P, Q, R. First thing, all sides are equal. So if this is 3 centimeter, then this will also be 3 centimeter, 3 centimeter, 3 centimeter. Then another thing, all the angles are right angles. Right angles. All angles are equal and right angles are 90 degrees. All of them, they measure 90. Okay. So, also, there is one more quality. Suppose if I need diagonals in it, they will bisect and they will bisect each other at right angles. Okay, and the diagonals, the length, the measure of the diagonal is also equal. Okay, the two lines of red that I've drawn are the diagonal of it, and its measure is also equal. They will bisect each other at right angles. Okay.
Ma'am, could you repeat that again? I didn't hear you.
All right. Yes. So now in my square, the lines that I've drawn inside, two lines with red, they are known as the diagonals of a square. Okay. PR and SQ are the diagonals of a square, of this square, and they are equal in measure. Okay. Suppose PR is 3 centimeter, the diagonal inside, then SQ will also be 3 centimeter. The diagonals, okay, equal measure, and they will bisect the 90-degree angles. They will bisect both the angles. Okay, they will bisect each other at right angles. Means they are bisecting the both right angles. Angle S and Q and angle P and R. They are bisecting. Means they are cutting them in half, dividing them in half. If it's clear. It's all sides are equal. equal to 90 degrees. Diagonals of a square are equal.
Equal and bisect each other at right angles.
Yes. Bisect each other, right? Any doubts in this one?
No, ma'am.
In the when it is bisected in the diagonal,
Mm-hmm.
uh,
Yes.
the angle S and R, there's no midpoint, but that angle, is it a right angle?
All the angles, angle S, R, P, Q, all four are right angles. Okay. All of the four angles made at the corners are right angles. Okay. All right. So shall we move forward? We will
Okay,
see
ma'am.
next rhombus and then pan. Okay. Let's move to rhombus.
Ma'am, just give me a minute.
Okay. All right.
Yes, ma'am. Thank you.
Okay. Let's see the next one. Rhombus. Let's move it. Now about the policies of a rhombus. Same like the square, it has all the sides of equal measure. Okay. All sides are equal. But what is different in a rhombus? That the angles might not always be 90 degrees. Okay. Angles are not right angles, but they are right angles sometimes, but not always. Okay. The measure can be different than 90 degrees. Alright, so that is different. In square, always we will have all the right angles. Okay, all the angles will be right angles. But in a rhombus, it may not be a right angle. Always. Okay. Also, in this also we are having diagonals which bisect the angles into
Ma'am?
rhombus also. Yes, actually.
Ma'am, are they bisect at right angles or no?
they will bisect at right angles if right angles are if the rhombus has right angles. Okay, rhombus might not have right angles sometimes. Okay. All the signs are equal. May or may not be right angles. Then opposite sides of rhombus are also parallel. Okay? This side will be parallel to this side. This side will be parallel to this side. PQ parallel to SR and PS parallel to QR. Okay. Opposite sides of a rhombus are also parallel. Then diagonals bisect angles into two. Okay.
All
So
sides are equal to each other or only opposite sides?
all sides are equal. All sides are equal, but not all angles will be right angles. Not all angles will be right angles.
So then why did you make the mark like one side, two opposite sides have one line and the other two opposite sides have two lines?
Because the opposite sides with one line are parallel. This is the parallel. Okay.
Ma'am,
And,
Okay.
yes, I'm sure.
ma'am, the diagonals of a quadrilateral always make four triangles.
Yes, they make four triangles. That's right. They will divide the whole quadrilateral into four parts, four triangles.
Ma'am,
Yes.
and a
Yes,
quadrilateral always has two diagonals.
yes, that is correct. All types of quadrilaterals, squares, rhombus, all of them may have two diagonals. Okay. And what I was saying
Yeah, ma'am.
is that, okay, every square is a rhombus, but a rhombus may or may not be a square.
If
Okay.
one angle is right, then are all the angles right also?
In a rhombus, you are talking something.
Yes, in a wrong.
One angle maybe can be right angle, okay, or there may be more right angles, or it can be that the angles are not right angles, okay, both the ways. But then what is the main thing? That its sides are equal. Okay, square, we have all the angles are right angles, but rhombus, it may be right angle or it may not be a right angle. It may not be right angles. Okay. But in square and rhombus both, all sides will be equal. That is the thing. But the difference is that in square, all angles are right angles. Rhombus, it may be a right angle or not. Okay. Alright. So let's do the last one. That is kite. I'm going to clear this screen. Any doubt? Any other doubt? Any?
No, ma'am.
Zara, hope it's clear.
I understood.
Okay. Alright. So let's do kite. Yes, Amina. One angle is 90 degree. Others will also be 90 degree. So we have the kite E, Q, R. Okay. Now, this is a quadrilateral. Okay. This is also a type of a quadrilateral. And its adjacent sides are equal. Okay. Its adjacent sides are equal. This side will be 1 minute. Yeah. This side will be equal to this side. Equal
Ma'am?
and yes,
Ma'am, it's called a kite.
yes. And this side and this side will be equal. This also has two diagonals.
And every single quadrilateral will have two diagonals.
Yeah. Okay, but its measure is not equal. The measure of the two diagonals is not equal in type. Okay, so you can write it down. Its angles are also not equal. Okay, all the angles are also not equal in measure. adjacent sides PQ and PS are equal. And RS and RQR. It's also made in this form sometimes, like this. So you will have the adjacent sides equal to each other. Okay. And the diagonals.
Done, ma'am?
Okay. Hope everybody has written.
Yes, ma'am. Next.
Because I'm going to clear it. So now we will try out some questions on body matrix. Okay. Some questions on body matrix. So a body matrix has three acute angles. Each measure 80 degrees. Find the measure of both angles.
Ma'am?
Yes,
Ma'am, is it 120 degrees?
yes, that is right. All of you all, please try this now.
Ma'am, the fourth one is 120 degrees.
Yes, that's right. Singing Zara, hope you are getting it. Okay. So let's see how 180 degrees. Okay. Let the fourth angle be x. We can assume the fourth angle be to be x.
I'm also getting 120.
Okay, very good. So sum of the angles of a quadrilateral is
Ma'am, 360.
Yes. Sum of all the four angles of a quadrilateral is 360. So 80.
Ma'am,
Yes.
ma'am, for triangle it is 180 and for quadrilateral it is 360.
That's right. Triangle is 180, quadrilateral is 360. Okay. So this becomes 240 plus x equals to 360 degree. X equals to 360 degree minus 240 degree. That is 120 degree. So measure of fourth angle. Angle is 120. So like this, if questions are put up on the quadrilateral, we can find it. Because we know what's the sum total of all the angles. So any other measure is asked, we can just calculate it. Okay. Shall we move to the next one?
Yes, ma'am.
All right. Next one. In a quadrilateral, ABCD, this is the name of quadrilateral.
ABC.
D. Angle D is
Ma'am, why
equal
do
to
we
160.
name ma'am, why do we name a quadrilateral with four?
Because it has four vertices, four sides and four vertices. That is why we name it with four vertices. Okay. So in a quadrilateral ABCD, angle D equals to 150 degrees and angle A equals to angle B equals to angle C. Find angle A, B, and C.
Ma'am,
Yes.
ma'am, ma'am, is it 70 degrees?
Yes, that's true. Please write out all of you if you're getting the answer, the measure of angle A, B, and C. Please write out.
Ma'am, I got 70 degrees.
Okay.
Ma'am, I got 450 degrees.
You got 250 degrees. Okay, that is the sum. That is 250 degrees.
450.
450 degrees. Okay. Can you just check it again, please? Okay, so it's given that angle to the is 100. Okay. So we can assume that A, B, and C are X.
I think angle A, B, and C are equal to 70 degrees.
Yes. Yes. Okay. So now we can do again the angles and property. Angle A plus angle B plus angle C plus angle D equals to 360 degrees. So X plus X, because above we assume that A, B, and C all at X. Okay. T is 150 equals to 360. So this X plus X plus X, when we are adding X 3 times, it becomes 3X. Okay, 3X equals to 3X plus 150 degree plus 150 degree equals to 360 degree. Now we can take 150 that side to subtract it because variable one side, number one side. So 360 degree minus 150 degree. What comes? It comes 210 degree. 3x equals to 210 degree. Now to find the value of x, we will take this 3 on the number side. Okay. Here it is a multiplication. Here 3x is a multiplication. We take it to that side, it becomes divide. Okay. So x equals to 210 by 3. 210 by 3. 3 ones are 3 sevens are 21 and C. X equals to 70. Okay. So we will get that angle A equals to angle B equals to angle C equals to 70. Any doubts, anyone? Is that all? Hope it's clear how we are getting 70. Clear, everyone? First, the question says that A, B, and C are equal. Okay, so we will, and we know that the angle B is 150 and the total is 360. So what you can also do is you can subtract 150 from 360 and then you can divide the remaining, that's 210 by 3. You can divide the remaining. 210 is the sum total of angle A, B, and C. When you divide it with 3, because 3 angles are there, so you will get 70 degrees. All the 3 angles will be of 70 degree dimension. That's how we try it. That's how we solve it. Some questions I'll be giving you for homework and some questions we will try out in the next class. Okay? Alright, so we will stop here and we'll continue the rest of the portion tomorrow.
Ma'am, what's the homework for today?
Can you repeat it?
What is the homework for today? Homework?
Homework for today. Homework I'll share in the group. Okay? I'll share the questions in the group. Sarah, I'll add you in that. Okay? And I'll share it to all of you. Okay, so homework I'll be sharing, and the rest we will continue in the next. All right, then see you all the time.
Bye.
Bye,
Bye, Ajay.
ma'am.
Thank you.
Okay, Zara. Bye. And I am thinking, please stay back. Science class will happen. 5 minutes break, and then we will continue. Okay, let's begin. Hope you all are there.
Yes, ma'am.
Videos on, please. Yeah. So in the last class, we were doing reflection. Right. We saw its two types. These are the two types of reflection. That's regular reflection and irregular reflection. Today we will do the laws of reflection. Okay, laws of reflection. So the first law is that the point, the reflection point and the point of incidence are generally comparable. Okay. Basically, it says that the angle of incidence is always equal to the angle of reflection. Angle of incidence is always equal to the angle of reflection. Now, this is my mirror or anything like this. Okay. And this is my incident ray falling on it. Incident ray. This is the reflected ray. Here the incident ray fell and here it got reflected. Okay. Now, if I draw the normal line that is the perpendicular here over here, it will bisect the angle. Okay. And we will have the our two angles. This is angle I and this is angle R. Okay, this is incident here. This is reflected here. Okay, this is normal. So it's forming two angles, angle of incidence and angle of reflection. Okay,
And
so
both are
now,
same.
yes,
Ma'am, what is this normal line you have drawn in between the incident ray and the reflected ray?
the normal line is a straight perpendicular line, okay, that separates the plane of incidence and the plane of reflection. Okay, what is the plane of incidence? This side is the plane of incidence, and this side is the plane of reflection. But if I'm not drawing the normal, how will I get, how will both the planes be separated? Okay. How will it be separated? So to create that separation, we draw a perpendicular line in between the angles that's made by incident and reflected ray. We bisected it into two equal parts using the normal line. Alright. So to separate our incident plane and reflected plane, we used normal. Now, 1 minute. Coming back to the law of reflection. What was the first law saying? First law saying that was saying that the angle of incidence is always equal to angle of reflection.
Will you write it down, ma'am, please?
Yes, I'm writing it down. Of incidence will always be equal to angle of reflection. That is I equals to angle R. Okay. Now, the reflected light will follow the same path if the original beam strikes the plane mirror at any other angle, at an angle other than the usual. Okay, what does it mean? See, this path that this line is it's coming in this path, okay, it will reflect right back on the same path. It will reflect right back in the reflection when it was on. Just like that, it will reflect. If it is a plane mirror, or if it is a plane mirror, like I taught you all, regular reflection, that it will go reflect the same way it's coming. Like it's coming like this, it will be reflected like that. Okay, same way it will be reflected. Alright, so that is basically what happens here. You can write it. You can write this thing also. This is what it means when it says that the point of incidence and the reflection point are generally comparable. Point of incidence.
Is this the second law you're writing?
No, the same one. And the point of generally comparable. Okay, and it's like the reflected light will follow the same path if the original beam strikes the mirror at an angle other than the usual.
Done.
One. Okay. All done. Next law. Here, draw a fresh diagram for this one. Now, this verse states that the point of incidence, incident ray, reflected ray, plane of reflection, plane of incidence are all located on the same surface. All located on a same surface. Suppose here I have my mirror. Let's take okay. Now incident rays follows like this. Okay. Okay. What happens? Reflected ray will fall like this in the same paths like we just saw. If the incident ray is coming like this, reflected ray will go like this. Okay. It will follow the same paths. Alright. Now, if I make the this thing normal here, if I make the normal here, I will get my this is I angle I angle of incidence. This is angle of reflection. Okay. This is incidence ray. This is reflected ray. This is plane wave. What is point of incidence? What exactly is the point of incidence? See, I haven't explained this, I guess. This point where the incident ray hits the plane mirror and then gets reflected at one point is known as point of incidence. Okay, that point is known as point of incidence. If I name this mirror PQ, PQ, okay, and this point I name it O point. So this O point will be my point of incidence. Okay, you can mark it. This is point of incidence. Okay, and this is plane. What this law is telling me, what this law is saying, that incident ray, reflected ray. Okay. Then the plane of reflection, the plane of incidence, the point of incidence, all of them are lying in the same surface, okay, or the same side of the mirror. All of them will lie on the same side of the mirror, the same surface. Okay, so let's write it down. all related to the water, same size. Okay, so look here. If I'm having my layer, yes, this is my mirror. Here. So I'll have my incident rate, reflected rate. No, okay. All running below the side of the mirror. Okay, same surface. If my mirror is placed like this, it's placed like this. Here. Then I'll have my incident ray, reflected ray, normal. Okay, and my points of incidence will be here, this point, and here, this point. These will be my points of incidence. Also on the same side, same surface. Okay, so this is the second law that we are talking. Okay. Any doubts still here, you guys? Anything you want to ask? Videos on, please. Okay, so this is the law. This is law also same if you kick a ball and there is a perpendicular line, then the angle when you kick it is same as how it bounces on, or does it only apply to the section? See, Suman, basically this only applies to reflection of light. Why? Because light always travels in a straight line. If you kick a ball, it might not travel in a straight line. Okay, because there is wind that may influence it. There may be some other factors that may influence the direction that the ball is going in. It can go like this and then like this also. Okay. It can touch a wall and then get deflected. But light, it always travels in a straight line. Okay. But if it goes in a straight line, then if the ball goes in a straight line, okay. Suppose this is my surface, any surface. The ball is here. Okay. It goes here like this in a straight line. Okay. Touches this surface, touches this surface here, the point of incidence, and then your ball comes here like this. Then your ball comes here. Then yes, both the angles will be equal. Okay. If your ball is following this path, this red path that I've made, and like completely making an angle, and then you put a perpendicular, both the angles will be equal. Okay, but mostly that doesn't happen. So mostly this thing is just used for the light. Okay, for the light.
Ma'am, I'm done writing.
And writing. Okay.
I'm also done.
Next. All right. Okay. So let's do the next thing. That is the formula. And this is very simple. Really simple. It's the
How
same thing
many
that
laws are there?
how many laws are there? Only two laws are there. Second, we have done the laws. We will see the formula. Okay, so we know that angle of incidence is equals to angle of reflection. Okay, basically this is the formula of laws of reflection. Then angle of incidence equals to angle of reflection. So we can say that reflected angle equals to incident angle, reflected angle, or reflected angle R equals to I. This is the formula where I is angle of incidence, R is angle of reflection. Because the normal line is bisecting is bisecting the angles into two equal parts. So we will have the angle of incidence I equal to R angle of reflection. Okay.
Done, ma'am.
Done. All right. Okay. So now we will do. There are two types of images. Sunil done. Shall I erase it?
Yes.
Sure. All right. So we have types of images. There are two types of images. Okay? Two types of images are there. One is known as real image. Another one is known as virtual image.
Ma'am, images of what?
Sorry,
Images of what?
of anything.
Okay.
Images of anything. Basically, the picture that's forming in front of our eyes. Okay. The image that is forming in front of our eyes. What is that image? Okay. So basically, there are two types of real and virtual. Now, imagine we are watching a movie. Okay. So now that image is forming, like we are watching a movie screen, or the image is produced on our retina, okay, the retina of a human eye. Those are real images. But what is a virtual image? If virtual images are reflections of objects in a plane mirror. Okay. They are reflections of objects in a plane mirror. Suppose you have placed a candle in front of a mirror. You can see the candle, you can see the reflection of the candle in the mirror. Now, that reflection of candle in the mirror is the virtual image. It's not a real image. Okay, it's a virtual image. So that is the difference basically between a real image and virtual image. Okay. Real image, we'll see it on a screen, the image will form on our retina. But virtual image will be a reflection formed in a plane mirror.
So if you are watching a movie, then is it a real image or a virtual image?
It's a real image. When we're watching a movie, it's the real image.
Would you please
Example,
write down the definitions of both?
sure, I write down the definitions.
Thank you.
Collection of a collection of focus points made by converging light rays. Collection of focus points converging light rays. And it is a collection of focus points made by backward extension of diverging rays. What are converging light rays and backward extension of diverging rays? I'll make a diagram and I'll show you all how the rays are converged in such a way that the real image is formed in our retina, and like how the in the virtual image how they are diverged in such a way that it is not an actual image but it forms a virtual image. How that happens, how the rays are reflected, all the story. We will do it in more detail in the next class. Focus points made by backward extension. Divergent rays. We can write the example. Watching a movie on screen. You can write an example here. Reflection of a candle put in front of a mirror. Reflection of a candle put in front of a mirror. Or we are going to see the diagrams of this format.
Done, Mom.
Here and okay, Simeon done.
Yes.
Okay, so then we will stop here. We'll continue from here, from real and virtual images in the next class. Okay, tomorrow, I think you guys are having math test, right?
Yes, Mom. Tomorrow we're having chapter 12.
Chapter 12 math test is there. Okay.
And what about science test this week? Is there any science test?
I'm planning for a science test on the 9th or 10th. 10th, I'm thinking of
10th is Friday, right?
Thursday.
Thursday.
10th is Thursday. So, will it be okay with 3 days for the preparation? Science test.
If we do what? Sorry?
Like, if we keep it on 10th, it's fine, right?
Yeah, it's fine for me.
Yeah.
Okay. Okay, then. Okay, so I'll see you guys tomorrow. Bye.